And so the word bug's been around for a while. According to the dictionary, it originates from Edison's phonograph. Or at least it was used in 1889 to refer to a bug in Edison's phonograph. So it's a defect or a fault in a machine plan or the like. So it's an old term. In computer science, Grace Murray Hopper is usually credited with using the term, and it came from a moth, an actual bug that got into the Mark I computer and caused it to malfunction. And they removed the bug from the computer and put it in the logbook. I don't know if it still exists. Maybe there's a computer museum somewhere where you can see that actual bug. Now, when I was younger and when she was alive, I went to a talk she gave. And the thing I remember about the talk is she talked about how she tried to get students to understand the difference between a microsecond, which is a millionth of a second, and a nanosecond, which is a billionth of a second. And the way she did it was she held up a coil of wire. So it was a pretty long coil of wire, maybe 1,000 feet long, and said, this is a microsecond. This is the amount of time it takes electricity to go from one end to the other is a microsecond. And then she had nanoseconds, and she had a whole bunch of smaller wires, like a foot long. And she would hold them up and say, this is a nanosecond. And she gave the nanoseconds out to the people at the talk. So for a while, I had that wire. I'm not sure what happened to it. But that's my recollection of her. There's a bad psychology to the term bug. It makes it sound like it's not our fault. See, there's a bug in my program. You know, it's like something happened to you, something unfortunate happened to you, as opposed to it's a mistake or a defect, and you put it there. So just using the term bug puts you in the wrong mindset for finding this, you know, for solving, for debugging. Yeah.
Could it also be that we're using the term, like, as computer scientists, we're using bug in the terms like, say, a user would, where, oh, I experienced a bug, it's completely out of my control, whereas as computer scientists, we have control over that, but we're still using it in that user-like way?
Yeah, I suppose you could say that. You know, when you're using a program, you talk about a bug, and it's not your fault. But yeah, you got to have a different mindset when you're developing with the debugging program that you wrote. How we doing? All right, so I want to start by talking about 3 bugs that I've suffered through in the last few months. So this is bug number 1. I had a student develop over the summer what he calls CPM, Canvas Project Managers, and we used it in CS 1410. And what it is an Eclipse plugin that lets students download Java projects directly from Canvas. So rather than having to download it from Canvas and then import it into Eclipse, a multi-step process where students always manage to make mistakes, you just, in the CPM, you just browse through the available projects your class has, click on the project, and it's automatically installed into Eclipse for you. And you can go the other way. When it comes time to hand in your solution, rather than export it and then hand it in, you just right-click and submit it, and it goes in. So it's a pretty handy thing. Now, since it's dealing with Canvas, you have to authenticate. And so the way it worked was, when you fire Eclipse and you try to use a CPM, you have to log in, just like you do when you log into Canvas. And behind the scenes, what's happening is Canvas is getting a long string of numbers called the refresh token. And not Canvas, the CPM is getting that refresh token because after you've logged in. But then as long as the CPM holds that token, it can ask for what are called authorization tokens, and those authorization tokens are good for an hour of interaction with Eclipse. And when they expire, you use the refresh token to get the next one. And so early on, we were wondering, should we save that refresh token on disk so that next time you run Eclipse, you don't have to log in, or should we not? And we decided not to save it. And so every time, students began to get annoyed. They constantly having to log into Canvas every time they went to run this thing. So I made some modifications over Christmas at the beginning of the semester and created 2.0. And one of the modifications was to save the refresh token to the Canvas workspace. So you can log in once at the beginning of the semester and you're authenticated for the rest of the semester. Nevertheless, after I'd made this change, every time I would restart CPM or Eclipse, the user would be forced to log in because evidently the refresh token wasn't working. And this took 3, 4, 5 days of working on it to find the problem. So I've given you only a very high level and vague description of what was going on. But what do you suppose, what would you think? Where would you look if you had a bug like this? Yeah?
Maybe anything that takes in the token I would look at. Like a sort of
Okay. Anything that looks at the token? Okay. Yeah?
Saving the token to disk. Maybe something went wrong in there.
Okay. Is it being saved correctly? Yeah?
See what, if any methods are causing unintended side effects that are modifying.
Okay. Look for unintended side effects. Yeah?
Make sure the token is being retrieved successfully.
Make sure the token has been retrieved successfully. And how would you investigate all this stuff? Well, he just said debug it, but how? Yeah?
Test each individual thing you do. Make sure it saves properly, like unit testing.
Okay. So unit testing, certainly would help, yeah.
Putting breakpoints in your code to make sure that values are what you expect them to be.
Okay, put breakpoints in your code to make sure values are what they're supposed to be. Think of any other techniques to use, yeah?
Maybe go half of the process, have a breakpoint, check that's there, and then you can determine what happened and then just kind of narrow it down.
So let me tell you what I did. I did a lot of the stuff you suggested. I did a lot of stepping through the code. And at first, I say it's forcing me to log in. And so I went and I made sure that what I thought was maybe the refresh token was being recorded, was being written wrong to disk. And so I did a lot of checking. I would print out, it's yay long, so you can't memorize it. So I would print out what it was when it was actually working after I logged in. And then I would go look on disk and make sure that it was stored in the file on disk exactly the way it was supposed to be. And then when I started back up, I would make sure that it was exactly like it was supposed to be. And every time I looked, it looked fine. And yet, I verified that it would take that token, it would send it to Canvas to obtain a refresh token, an authorization token, like it's supposed to. But back would come a message that the refresh token was invalid. So something was wrong with that token. Where do you go from there? Yeah?
Also, with Canvas, sending you the token in one format, and as you saved it, and then resent it, at some point it would get changed.
Okay, so yeah, you can wonder.
Repeat.
He said Canvas sends back the token, maybe it sends it back in the wrong format or a different format. Yeah?
Maybe Canvas only accepts that particular refresh token for so long, sends you a different one next time you log in.
Okay, he's saying maybe the refresh token expired, but the documentation said it would last indefinitely. Yeah?
You use a dot equals method, dot equals on the token to see if it's still the same result.
Yeah, I don't know if I did that or I just eyeballed it, but they were clearly the same. And the thing that I did was, I did all this stuff, and then I started to doubt myself. I said, did I really do this carefully? So I'd do it all again more carefully. And I got to the point where I was talking to people at work about it, about this mysterious bug, and I was starting to feel persecuted. Starting to think maybe there's a bug in this authorization, this whole authorization thing. And finally, I decided I need to back up and think about it from a broader perspective, because I was focusing on the code that stored the token and read it in and reauthorized with it. And that was working flawlessly. The problem was the original CPM and the new CPM had a feature that when the CPM shut down, when Canvas ended, it would revoke the refresh token on Canvas. It would delete the refresh token from Canvas. It would invalidate it. Because after all, I was throwing it away, and we wanted to remove it from Canvas because it actually shows up in Canvas. Right? We were ending up with long lists of old tokens, and that seemed bad. So that's what was happening. Every time I shut down my testing to simulate logging back in, a side effect of that was the token was being deauthorized, so it didn't work. I had the old token, but it didn't work anymore. So what's the lesson to learn from that? I always try to learn lessons from my bugs. What was my fundamental problem? Yeah?
You were zoomed in too close on where you thought the problem was, so you couldn't actually catch that it was farther back?
Yeah, she said I was zoomed in too close on the problem. I had tunnel vision. I was convinced the problem had to be here, and it was over there. You know, it was code tucked away that I wasn't even calling anywhere. It was event-driven code. It was just event that when the shutdown event occurred, it ran. So it wasn't even on my radar. I'd forgotten it was in the program. But when I gave myself permission to stop focusing in on this and back up and think about think about it logically. We've ruled out all this other stuff. All that was left was the token had been invalidated. And once I allowed myself to think about, the token has been invalidated, I suddenly remembered, yeah, of course. That's what the CPM does. So I had to take that little bit out of the CPM because we didn't want that to happen anymore. Yeah?
How do you know you've reached the point where you can say, I trust that I've done everything I could looking this close. I need to step farther back. Like, how do you know when
how do you know when to do that? I think most of us don't do it soon enough. Right? We'll talk more about approaches to debugging, but in the end, when I've had problems with debugging, it's very often because I'm just not thinking logically. I get too emotionally invested in this thing. And when I finally stop and back up and just think about it holistically, I can find the problem. Okay, here's bug number 2, also involves a CPM. So when the CPM downloads a zipped project, it automatically unzips it into Eclipse. So what we would typically do is for a problem set, I usually give the students a starting point. And so I would create the starting point, say call it ps1.zip, stick it on Canvas, and then when a student wanted to start PS1, they would go and click on PS1, it would get that zip file, bring it in and expand it in Eclipse. And there's a configuration file that sits on Canvas's file system so that the CPM can find the projects to use. So when I was modifying CPM 1.0, I added some features, but I also decided to refactor the code. So I was making extensive modifications that weren't supposed to change the behavior, just make the code easier to understand. So I started testing version 2.0, and I found that when I downloaded PS1, I would get an unhandled exception. And I finally figured out that the problem was the source folder, for PS1 I didn't get a starting point. It was just sort of an empty project. And so the source folder was empty, and empty folders were triggering this problem. Nevertheless, 1.0 worked just fine all semester previously. I was just working on the old projects from the previous semester. In PS1, no one had reported a problem using CPM of PS1. So what I did was, I said, okay, it used to work, now it doesn't. What would you do? Yeah?
I'd assume that I probably copied and pasted something into the wrong spot
Right.
and ruined everything.
Right, I got an old version works, a new version doesn't. So I must have put some bug in. I didn't want to leave that bug in. I needed to find it. And so I started comparing code. And it was difficult because I had extracted some code into methods. And so I spent a lot of time just sort of matching up, how you would step through this. And I never could find a problem. I could not find a problem that I had put in. What do you think was going on? Yeah?
Maybe the way that you restructured it, it was just the way it handled the data types. Maybe it just couldn't read the source folder.
Okay, so maybe, so some aspect of the restructure, but the code was, I'd rename variable names, but I could see statement by statement. It was going through the same steps. Yeah?
The IDE was not set up correctly?
The IDE was not set up correctly? Okay, that's a thought. Yeah?
You expected one exception that maybe was happening in Canvas before, but now is a different exception because they've updated code maybe, and you're not handling it appropriately because of that?
Yeah, maybe something changed, but yeah, possibly. Any other ideas? This one was more frustrating than the one before. I burned more time on this than the first one.
Oh, wow.
And the thing to realize is, CPM isn't being used this semester. I'm not teaching 1410. This wasn't even on the critical path to anything I needed to accomplish this semester. I needed to be getting ready to teach this class in 4150, but instead I was just drawn to, I wanted to finish this thing, and I was stuck on this bug. Any other thoughts? Yeah?
Is it possible you actually had a bug in CPM 1 that wouldn't necessarily check
Okay.
that I thought it was supposed to
Okay, so he's saying maybe there was a bug in CP1 to start with, and possibly, yeah.
Maybe when you were fixing it, maybe a different bug that caused this to stop working, right?
Yeah, but the code, again, these are all good ideas, but the code, I would doubt that I'd done it thoroughly, and each time I would spend even more time making sure that what I had concluded was right. Now, so let me tell you a few other things. It seemed too painful to recreate. So a student had developed version 1, and so he had all the development stuff for that half of the project. And so I didn't feel like reconstituting an Eclipse workspace that had version 1.0 ready to test. So I was just going on the fact that 1.0 obviously worked the previous semester, and that this didn't. And I was comparing lines of source code. I wasn't actually running version 1 in a test environment.
Oh.
Okay, so that was a mistake, because the problem turned out to be the CPM version 1.0 had the same bug. So I spent days looking for a difference when there wasn't a difference. CPM 1.0 had the bug. So now you start wondering, well, why did it work? And the difference was that configuration file. One thing I changed between the two versions was the way the configuration file was written. And it turned out that in version 1, in the old configuration file, I had not put an empty project in that was zipped up. And CPM's behavior in that case is to create an empty project on Eclipse. So if it can't find a project to download, it'll create a project by that name in Eclipse and make it empty. So CPM 1 was just building the empty project. CPM 2, my configuration file actually pointed to an empty project. And so it was downloading the empty project and unzipping it. Both of them had this bug when there was an empty folder, an empty source folder. So I was working on a bad assumption. There was something I didn't understand, and I didn't realize I didn't understand it. And that can also happen a lot. You think your knowledge is perfect, your knowledge isn't. And that took a long time to admit that, I'd made several mistakes. If I had actually been testing, in a test environment, 1.0, I would have found the bug a lot faster. And if I had tested my assumptions, questioned my assumptions a lot sooner, I would have found it a lot faster. Now, do you think it's unusual that whenever I have trouble with bugs, it ends up being some weird thing? Don't I ever have bugs that are just garden variety bugs? Yeah.
I assume so, but you can't deal with them so quickly that it's like you work on it for 10 minutes and it's solved. It's
right.
Like a 3 or 4 day problem.
So, over the years, I've gotten good at debugging, and most bugs that I find I can find really quickly. So it's the ones that end up being memorable, the ones that take all my time, are the ones that are, a type of bug I've never had before. And hopefully I learn from the process and go forward. But the better you get at this, the more frustrating the bugs that you can't figure out become. One more bug, bug number 3. So as you know, we've been live streaming lectures. And we're doing it in, Stefan has organized it all, and we've got 2 different kits, and we're doing 4 classes. And we have this incredible mixture of laptops, like I'm using a Windows laptop, other lecturers are using Macs. We have got components like HDMI splitters and capture cards, video capture cards. We've got stuff plugged into different outlets. We've got connectors galore. And we've spent 3 weeks trying different combinations of things, trying to find something that works well in all these combinations. And we've had complete disasters along the way, like a couple weeks ago where we had a week of audio in this class in 4150 that just didn't, large stretches where there's basically no audio. But we finally got it all sorted out, we thought. And then Stefan reports that he's been listening to the audio on our recent videos and finds that about every 5 seconds the audio drops out. And then it comes back up, and then 5 seconds later the audio drops out, and then it comes back up. It's this rhythmic dropping of the audio that he said was really annoying. And so we're brainstorming, trying to figure out, okay, what's causing the problem? This is more like hardware debugging, And when this happens, we come down here when there's no class and we set things up and we try all these different combinations. We couldn't figure out why audio was dropping out. So, what do you think? We found the problem. What do you think it was? Yeah?
Loose cable connection.
Loose cable connection? That's a good guess because, you know, every time I brush against this one here, it sometimes flashes that, but that wasn't it, yeah?
Hardware?
Well, hardware, I think that's a given that it was hardware somewhere along the line, but, yeah?
Like a bad outlet or something?
A bad outlet? Well, I'll tell you, just before class, Stefan plugged his cell phone into charge on the power strip down here and happened to notice it wasn't charging. That's when he noticed the power strip was shut off. So that would have been a problem, but that wasn't it, yeah?
Is it possible that maybe some laptops, like USB ports or something, they have a bit more power than other ones?
Okay, we've certainly had a problem with devices that were supposed to be powered by the USB connection weren't because the cable was too long, but that wasn't it, yeah?
So was it pretty regularly, like every 5 seconds?
Is that about what it was, yeah? Every 5 seconds, yeah?
Would it have been like a mismatch in audio sample rates?
Would it be a mismatch in audio sample rates? Nope, that wasn't it, yeah? I'll start with you.
Maybe like YouTube Live, you upload every 5 seconds, and there's some sort of setting somebody forgot to check where like fades out at the end of this video. I thought
Okay.
each 5 second was a...
Right, so maybe YouTube is at fault?
They're not even in the ballpark.
No, they're not, yeah?
I was thinking maybe if there's another program running on your laptop that kicks off every 5 seconds, or something else that you're
Okay.
using that kicks off every 5 seconds that might be interfering.
Something happening on the laptop, yeah. We use different laptops in different lectures, and that was still showing up, yeah?
Maybe you have an off-brand HDMI cable that's not properly up to spec.
Off-brand HDMI cable, I can't tell you how many cables we've been through trying to find.
Think outside the box. You guys aren't even
outside
close.
the box, that's right.
Maybe you have one of those programs that like gives the computer a jolt every 5 seconds to keep it like to keep it.
Okay, no jolting, yeah?
Your upload bandwidth isn't enough, and so it has to choose between audio or video.
Is choosing whether to preserve the audio or the video? No, that wasn't it, yeah?
Maybe you were moving away from the mic every 5 seconds.
Okay. That's reasonable, but it was happening not just to me, yeah?
Switching between audio capture devices?
Switching between audio capture device? No, that wasn't it, yeah?
It happened with all classes, both kids.
Yeah.
Running low on memory, potentially causing slowdown or?
Running low on memory, slow down? No. Here's what happened. So Stefan's in my office, and he has his cell phone, and he's listening to your music on it, right? Listening to something on it. Let's say he was listening to music, and he puts it down, and he has like this really wide eyes, and he says, I understand the problem. He was just listening to something had nothing to do with our videos.
Earlier I had been.
Yeah, earlier. He's listening, and he notices that every 5 seconds the audio drops out. The problem was with the Bluetooth on his phone. So he had been monitoring the audio on our. When he monitored the audio, it was via his phone, via his earplugs. The bug was in his phone, not in his cell. So this is another example of where we're all looking in the wrong place for the problem. We just see this mass of cables and things laid here, and surely the problem is there, but no, it had nothing to do with that. Which may explain why no student ever said, oh, the audio is dropping out every 5 seconds. All right, so those bugs happen in the space of, like, all of them, 3 weeks. So it's been sort of a fertile 3 weeks for examples. So I think you might all agree that debugging is a difficult task. I mean, when you're developing, how much time are you spending programming initially versus debugging? What fraction of your time do you think you spend debugging?
I feel like 50% I'm spending debugging.
Okay, 50%, does that sound right?
Give me a 70.
Higher.
70% higher? Okay. So why is it difficult? Well, most programmers aren't very systematic about it. You know, they sort of get frantic, and especially if there are deadlines involved. Many programmers learn one technique and stick with it. And what do you think is the favorite technique of many beginning students for debugging? Print statements. And they have their place. But that's not the only, the only trick you need to know, the only tool you need to know. And, you know, it's difficult just because software is complex. Programming is hard. It's scary because it takes an unpredictable amount of time to find a bug. I mean, the bugs I'm talking about, the first two, I can remember many, several nights in a row where I was sort of working on it, and I would say, okay, I'm going to find this before I go to bed. And I didn't. And I said that the next night, and I didn't. So even after all these years, I wasn't very good at predicting how long it would take to find the bug. And then we need to talk about what's the result of successful debugging. So when you've successfully debugged something, you should have test cases that reveal the defect. Why is it important to have, when you find a bug and fix it, why should you keep the test cases that let you discover the bug in the first place? Yeah?
Because if you change the test, you could have fixed the test but not fixed the program. Like, or if you change it the other way.
Okay, but even, you fix the test, why keep that, you fix the bug, why keep the test? Yeah?
If you change your code later on, you don't want to introduce that bug back.
Right. You want to have a test case around to detect that bug if it happens again. Don't throw away any test cases that help you find the problem. It's good to have committed versions of the original and the repaired program so you've got a good record of what the fix was. And it's good to reflect. You can make notes or whatever. Notes about the nature of the mistake you made, so maybe you won't make it again. I know that both of those first two bugs, I made them, and then I was thinking, these would be great class examples. There's no way I'll ever forget the details. And then like 2 days later, I'm going, what was that bug? And like this afternoon, I had to sit, getting ready for class, trying to remember exactly how these bugs unfolded. It's amazing how fast you can forget something that dominated your thinking for a number of days. So you want to make debugging rarer and easier. So one way is to make, we keep talking about best programming practices, instance variables project, invent your code, use meaningful variable names. The more you can improve your process, the less likely you are to make mistakes in the first place. We'll talk about Judys Law in the next slide. What should you not do when debugging? Right? You should not guess at what the problem might be. You need to think about it. You need to be scientific about it. Don't randomly scatter print statements hoping something will materialize and you'll see some pattern. Don't randomly step through the code. Don't get rid of old versions of code. How could old versions of code be useful? Yeah?
Well, if you fix something and then need to come back to it, you can just have your old version.
Right, so, if the bug didn't exist and then you modified it and now it does exist, it's nice to do a diff. So frequent commits can help you so you can see what changed. You can't debug unless you understand the program. And this, I can't tell you how many times in my life I've done that. I have become convinced that the compiler has a bug, or that the runtime library has a bug, or the operating system has a bug. And each time I've been wrong. I've never found a bug in a compiler.
I did once.
So I'm not saying there are no bugs in compilers, but most of the time it's not a bug in a compiler. Okay, Judy is my wife. She was also a software engineer for a time, and she's taught me Judys Law. So Judys Law says that if something seems wrong but you dismiss it, it will come back to haunt you at the worst possible time. Now, Judys Law applies not just to software, it applies to life in general. So I'll start with the last example. This is an example of Judys Law. You see a puddle of water under the hot water heater. And so you say, that must just be condensation. It's a humid day. Okay? So what does Judys Law say? Yeah?
That it'll blow up your house while you're not there.
Maybe it won't blow up the house. What's the reason for water under a hot water heater? It's leaking. And leaks just get worse. And so probably when I'm not home, it'll leak and flood the basement. Okay? And that's all because I don't want to deal with the problem right now. So I just want to make it go away. So I say, oh, the cat peed. And let it go away. Okay. So this happens. You're using your program and you see something and you realize, oh, that didn't seem right. But then, it's gone. And so you start questioning, did I really see it? Maybe you convince yourself it's just a glitch. You know, it won't happen again. Some server was down, so that won't happen. It only happens when that server is down. Or you might even admit, yeah, it's probably a problem, I'll think about it later. And what usually happens is you don't think about it later, and then not only do you have to fix it later, but there's some disaster that happens before you fix it, like with a hot water heater. So Judys Law says you better, when it's fresh on your mind, document the problem and look into it. At the very least, document it. So it doesn't come back and haunt you. I mean, we're constantly violating Judys Law. You don't really violate Judys Law, but something will happen in our lives when we look at each other and say, yeah, this is Judys Law at work, because we realize we've overlooked something we should have taken note of. So you can adopt a scientific process of debugging. I mean, what's the scientific method? If you're investigating nature, what's the scientific method say? Yeah?
Observe something, make a hypothesis, and then test.
Test it. Right. So the scientific method, you observe the apple falls from the tree, you wonder why, you make a hypothesis about gravity, and then you set about devising experiments to prove or disprove your theory. That's the scientific method, and you can apply that to debugging. The idea is you see there's a problem, rather than just randomly looking, you know, just sort of frantically looking for problems or printing out stuff. Stop, think about the error, and come up with a hypothesis for why it's happening. Then you've got a reason to single step through your code or print stuff out or whatever you're doing to try to prove or disprove the hypothesis. So first thing you want to do is stabilize the error. So what does that mean? What does it mean to stabilize the error? Yeah?
Make it so you could reproduce it again?
Right, you want to make it reproducible. So you want to, yeah?
I'm going to say you want to isolate it and make sure that that's the only bug you're dealing with. If you're dealing with like 3 different bugs and
Okay.
you don't know that they're in concert together, then you might fix one thing and not realize that you fixed something because there's other problems.
Right, so she said you need to isolate it. So at a minimum, create the simplest possible test case. Maybe have a complicated test case that reveals the bug. See how much you can simplify the test case and still have it be faked. And make sure you commit everything before you start. Commit the new test case, commit the buggy version of the program so you have a baseline. Nothing's worse than mucking around your program trying to find the bug, and instead you just introduce new ones and you've got no way of getting back to where you started because you don't remember the changes you've made. That's what version control really can come in. And this is where we get into the scientific method. You're now able to demonstrate the error. You want to form a hypothesis, design and run some tests, use a debugger, examine the code, whatever, to prove or disprove the hypothesis. And repeat until you locate the error. So always have a purpose to what you're doing. You're trying to prove or disprove something about the program. Then you repair the program. And I'm saying don't just patch the program, repair the program. Now what the heck does that mean? What's the difference between repairing it and patching it? Yeah?
The patch is if you have an infinite loop, you just have a counter that says, if I count more than 100 times, exit it because I think it's infinite.
Okay, so that's a good example. You notice you have an infinite loop, and instead of finding out why you have the infinite loop, you just say, okay, if the loop counter gets up this high, I'll just break out of the loop. And you observe that that seems to fix the test case you're failing. So you've sort of patched it. Yeah?
Yeah, patch is just a quick fix with repairing or thinking more in the principle of why it didn't work in terms of the broader picture.
Yeah, so you need to really fix the underlying problem. So if you notice that this method is failing when the parameter is 10, and you put in an if at the beginning that says, if parameter is 10, do this, that's just patching. You need to look a little bit deeper and try to fix the program holistically.
I have a question.
Yes?
Would like and or statements, would that also kind of fit in patching? Like if you have, okay, if this is true and this is false, would having the and also be kind of considered patching?
I mean, that's one way you could patch is by adding extra condition to the conditional. And whether that's a patch or a fix, whether that's a patch or repair, sort of depends on whether that much complexity is necessary in making the decision. Once you have a fix, you want to test the repaired program using all your test cases from the past. Just don't test the ones that was failing originally. You want to stabilize the repair, so commit everything. Include the new and documented test cases. Look for similar errors at that point. Are there any kinds of errors that you commonly make, that you know that you commonly make, that you make over and over again? Anyone want to say what they are?
I know I have some, I just don't know what they are.
Yeah?
I forget to put parentheses on the ends of methods often.
Okay.
If
Forgetting to
it's
put parentheses on the end of methods, at least the compiler helps you with that one.
Yeah.
Yeah?
If you're copying and pasting something, you forget to change variable names.
Okay, copying and pasting, forgetting to change variable names. And if you're unlucky, the compiler doesn't warn you because the names are declared that mean something else. Yeah?
I'll sometimes have a conceptual problem, which I'll find in one area, but then I'll repeat in a different area. And I'll just find it kind of stuff on.
Okay.
You're off by one is counted.
Off by one errors. It's called fence post errors often. Yeah?
And or.
Using it, that happens to me a lot. If I have combination of ands and ors and especially nots,
Yeah.
not this or that, I often scramble that stuff. Yeah?
Misunderstanding the spec.
Misunderstanding the specification. So the list goes on. I'll tell you a mistake, a small mistake that I continue to make after all these years. When I write nested loops, let's say I'm going through a two-dimensional array, I'll say for int I equals 0, I less than n, I plus plus. And then I'll say for int j equals 0, j less than n, I plus plus. So I increment I instead of j. And I've done this more times than I can count. And now I've finally become introspective enough that when I start to write the nested loop, I think, okay, you always screw up here. So if you can develop that kind of awareness, it will help you, help you avoid problems. I still make the mistake though. I don't always avoid it. So learn about yourself. I once had Chris Johnson teaches the class before me. When we were both first on faculty, we were talking about excuses we get from students, and we exchange funny excuses that we got from students, and it's the way parents talk about their children, the cute things they do. And he said I should keep a list of all the funny excuses I've gotten, and I could write a book someday. And I thought, well, I've already been teaching for 5 years. It's too late. So now it's 25 years later, and I really wish I'd done that. And probably could start today. But anyway, I wish I'd kept a journal of bugs the last 40 years, because I could barely remember the ones that happened 2 weeks ago. Peter Jensen, as some of you may know, he's always talking about some bug I had with a hash table that I've worked with him on probably 10, 15 years ago. I don't remember anything about it. He's teaching, he uses it in his classes, I think.
Could it possibly be that it's very traumatizing and you just want to put it in the back?
It could be that you don't like to own up to your own mistakes. So, yeah.
Or you're busy fixing so many other problems that each one just sort of slips after the last.
Yeah. Yeah. If you're doing got lots of bugs, you always slip into the past. I'm not done with this, but let's take a quick break. Start again. All right, so I got just a few more slides here on debugging. So a lot of this is just general platitudes. You want to use all available data to make your hypothesis. And if the data doesn't fit the hypothesis, don't discard the data. You just have to come up with a new hypothesis. The more different ways of reproducing the error, the easier it is to come up with working hypotheses. And don't be discouraged if you disprove your hypothesis. You're making progress. So, brainstorm for possible hypotheses. This is when I fixed my bugs. This is when I just said, that I just realized that I need to detach myself from this and take a break and then just think about it from a broader perspective. So a lot of times you get caught up right away with wanting to examine the code carefully or step through it. Brainstorm. Talk to other people. Yeah?
Do you have like a time limit on how long you're willing to beat your head against a wall before you ask somebody else for help?
Do I personally have a time limit? No, but I should, and so should you. I mean, sometimes you don't even need to talk to a TA or a student or anything. You could, talk to your mother or your dog. Sometimes just saying things out loud is enough to just hearing yourself say it. I mean, you probably all have the experience of trying to explain some problem you're having to someone, and you find the solution as you're describing the problem. And that can work if you're talking to a teddy bear. So, and taking a break is another thing. I can't tell you how many times I've solved problems in the shower, where I say, I give up, and I go take a shower, and then I think of it. Or I'm driving to work, and all of a sudden it pops into my head. So give those, give those things time to work, space to work. I like this one right here. Be suspicious of code that has had errors before. Okay? Why are places where there have been errors before likely to have more errors? Yeah?
You think that you repaired it and you patched it, and the patch doesn't work for what you're doing now.
Yeah, you repaired it, and maybe the patch was wrong. Or maybe you're just having a bad day and ripped that code in the first place. Yeah?
When you originally wrote the code, you didn't fully understand what it was supposed to do.
Okay? So there are various reasons for that. And we've talked about repairing the problem, not the symptom, so I won't go on that. And this is just what you got to remember. I've already said this. There's a logical explanation for what you're seeking. And I admit, I sometimes doubt that. There are cases where I think that the problem defies logic, and that the universe is out to get me. But there's always, always, always been a logical explanation, usually a fairly simple one. A lot of debugging is experience. The more you do it, the better you get at it. And taking a break is important, and talking to someone about it. These slides are so old, I don't remember what a Furby is. But so like some sort of stuffed animal that talks.
Yeah.
Kind of looks like a moth.
It's terrifying.
There are lots of debugging tools, the most important of which is your brain. But we've mentioned version control systems, ways to compare source code to see what's changed. Unit testing frameworks are important. Compiler warning messages are important. So you can go into Visual Studio, and there are ways, we'll have a lab in the future that talks more about this, but there are ways you can turn up the warning reporting. You can make it not just report things that are, the warnings have different levels, and so you can give it permission to give you more warnings. And you can even get it to give you reports about stylistic problems that don't affect correct running, but that might make your program easier to understand. And then there are the debugging tools in your development environment. So the lab tomorrow is to get you familiar with all the tools in Visual Studio that support debugging. And these are some of them. Breakpoints. I assume that you've all set breakpoints before. That's bread and butter. How many of you set a conditional breakpoint? Okay. So the rest of you, that's something to learn about. You can set a breakpoint and say, only break here if this condition is true. And that saves you having to go set a breakpoint and then hit continue like 100 times before the condition you're looking for manifests. breakpoints, conditional breakpoints. Single stepping, you can watch the values of variables. You can type in expressions and have them evaluated. You might say, what is x times y right now? You can see the call stack. You can make assertions about the code. So you put an assertion that says, at this point, I should be 10. And if it's not, you'll get a break. And there's something called IntelliTrace, where what IntelliTrace does is, while your program is running in debug mode, when important events happen, and that's configurable to some extent, like if an exception is thrown and then handled internally, it doesn't result in your program crashing, it's just handled internally, or certain I/O events, what VS will do is just automatically record the state of the call stack at that point. And after your program finishes, you can go back to any of these points and reset the stack to what it was when that thing happened. So that's a way of going back to the middle of the computation, basically going back in time. So that's all included in the lab tomorrow. All right, so we've had a lively discussion here about debugging because that's something we all have a lot of practice doing, a lot of experience doing. And just be aware that you can get even better. Any last questions or comments about this topic? Yes?
I wasn't having luck with the debug window, so I used trace and had a different program that was showing me trace output. For I think basically the same function where I was trying to get, what is this value here, and I want to be able to see it.
Right.
Is that adequate? Does that work? Is it doing something?
I'm trying to remember exactly. I would have to look at it with you sometime. Okay. So I'm having trouble remembering that. Yeah.
Is there a specific type of error that call stack windows are good for?
Well, call stack windows let you, so when you set a breakpoint, it's easy to see the variables in the current frame.
Yeah.
But with call stack windows, you can go back to methods that are currently suspended and see what their values are.
Okay.
I don't know what specific bugs it would be.
See, I was running into that issue when I was doing PS2 because like the variables would like disappear when I went from like line to line.
Mm-hmm.
Like, okay, I need to go check what the value of that is. So.
Yeah. All right, now we're going to move from this discussion of debugging, sort of a self-topic, to a different one. That's not what I want to be. Regular expressions. Okay, so regular expressions are a tool, as we'll see, a programming tool, that are really, really powerful. And but they're used infrequently enough by most people that whenever you need them, it seems like such a burden to remember how to use them that you just don't. And then later on you wish you had. So it's worth becoming good at regular expressions so that when you need them, you use them. And what they're good for is anytime you've got to look for patterns in things, for simple patterns in things. For example, in PS2, when you had to look for patterns in tokens, decide is something a double, constant, or is it a variable, or what? And there'll be other applications. So let me give you some definitions. So this is approaching regular expressions from a mathematical point of view. So from that point of view, a language is a set of strings. So it might be the set of all legal variable names, or the set of all floating point constants, or the set of all legal Java programs. These are all sets of strings. So there are some examples. The set of lowercase letters, the set of digits, or not the set of digits, the set of non-negative integers, that's an infinite set. Set of spreadsheet cell names, set of all C# programs. A regular expression is a pattern that describes some language. So a regular expression describes a set of strings, or matches, or we often say a regular expression will match anything from some set of strings. Not every language can be described with a regular expression. So the ones up here, those first three examples, you can write regular expressions that describe those patterns. But regular expressions are not powerful enough to describe the set of all C# programs. The pattern is too complex to express with a regular expression. So simple patterns are what regular expressions are for, but there are lots of times we need to be able to describe simple patterns. I'll give you one use case. Suppose someone says, here is a bunch of documents. I want you to remove all the Social Security numbers. Okay? So how would you do that? Remove all the Social Security numbers. Yeah?
You'd have a regular expression that counts for 3 integers, a dash, and 3 integers, and then dash.
Right.
4 more.
So you use a regular expression to describe the pattern of Social Security numbers, which is digit, 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 dash, digit, digit, dash, digit, 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 digit. And then it's a simple matter to take that regular expression and write a little code around it that just replaces every Social Security number, every string in the document that matches that pattern with X's or something, that redacts it or just deletes it. So otherwise, how are you writing the program? If you don't use regular expressions. You're doing you're doing substring. You're doing a substring operation that looks for the pattern. But how do you describe the pattern? So you do a search for a digit, then you check if the next thing is a digit, then you check if the thing after that's a digit. And you're doing all these manual checks. Your code gets really complicated. If you're doing that, it's time to use regular expressions. So let's look at some examples up here. This column, I have some regular expressions. This column just says what type of feature of regular expression I'm using. And this talks about the set of strings that that regular expression matches. So this is the simplest kind of regular expression, just text, hello. That's plain text, and it describes one string, hello. So there's your start. A regular expression can just consist of plain old characters, and then it just matches that exact string of plain old characters. Vertical bar has a special meaning. Think of it as or. So here we're saying that this will match this, or is, or test. And that's what it's saying. It would match any of those 4 strings. So it describes a set consisting of just those 4 strings. You can use parentheses for grouping. Those are also special characters. So this says that whatever I match has to end with a T, preceded by either D-O, F-A, H-A, or J. So these are the strings that we match. Right? This is called a character set. Square brackets containing characters. So that's saying this matches one character chosen from the sequence there. So take, it's basically a short way of saying D or F or H or J, followed by OE. So we get what you see down there at the end. These are simplified ways of creating character sets. This says lowercase a through z. This says 1 through 9. So this will match a single lowercase letter. This will match a single digit from 1 to 9. And that describes all these things. A1 through A9, B1 through B9, all the way down to Z1 through Z9. This negates a character set. So this is saying anything except an A, B, or C. So it's described any string of the form S, X, Y, Z, because of that, as long as A is not A through M. And surprised I skipped ahead to this right here. Parentheses are used for grouping. They have another application we'll talk about later. Star there, it means 0 or more repetitions. So we'll see what that means on the next slide. Okay? So these are simple, except for this one. This is the most complex one. These are fairly simple regular expressions that describe simple patterns. Yeah?
How do we know when we're using the caret for negation and for the beginning? I remember on PSP you had the caret and
right. So sometimes special symbols have different meanings depending on when they appear. It only means, complement is probably the right word. It has this current meaning when it's right after a square bracket.
Okay.
Yeah?
How does it work behind the screen? Is it like have some kind of loops over it, or?
Yeah, so behind the scenes, take 3100 for example, which a lot of you will. You get an idea for how this works, but basically the regular expression can be converted into what's called a finite state machine, a finite state automaton. And the bottom line is there's a loop looking for.
So for example, if we do like 1 to like 100 billion, that will slow down the program.
Yeah, I mean, it'll generate code, very efficient code that will do these patterns for you. Okay, repetition. That's what I started to talk about on the previous slide. I'll do it now. So question mark means optional. So that top one up there says you can have a 0 or not. Then 1, 2, 3, 4. We have their question mark would mean an optional A, B, or C followed by a 1, 2. Star means 0 or more. So 0, 5, star, 1 means you got to have a 0, then any number of 5s, and then a 1. You can see that playing out there on the right. You have no 5s, 1 5, 2 5, whatever. Star means 0 or more. So this would mean a 0 followed by any number of A's or B's, or both, any combination of A's or B's, followed by a 1. Plus is the same thing as star, except it means at least 1. So star lets you have 0 or more, plus means 1 or more. Same thing here. This means exactly 2 times. This means between 1 or 2 times, some range. And this means at least 2 times. Now that's a lot to memorize. That's part of the overhead of using regular expressions. You've got to learn how to write them. And they can get more and more complicated. But you write them a few times, you get used to it. But there's no substitute for practicing with them. Now, there are lots of special characters. So like dot will match any character except a new line, or any character, depending on what mode you're in. So we're getting into, that's a little more complicated. But basically, dot will match any character. Caret just matches the beginning of a line or string. $sign matches the end. Parenthesis has a special meaning. Put a backslash in front of it. It's just a parenthesis. New line, white space, non-white space, digit, non-digit, and so on. So, yeah.
So what is non-white space?
Well, let's say what white space is. White space is space, tab, new line, carriage return. Non-white space is anything else.
Oh, okay.
Just like digit. 0 through 9, and non-digit is anything else. Now, there are two parts of learning to use regular expressions. One is just learning how to write regular expressions. The other is, once you're able to write regular expressions, learning how to use them in C# or Java or Python or whatever language you're programming in. Okay? So what I want to focus on for now is just writing regular expressions. Forget about how they're going to be used in a program. What methods you use, what classes you use. Let's just focus on writing regular expressions. And we're going to do that by going to one of several websites for testing regular expressions. And this is called regex101.com. There are others. This is just the one I could remember the URL for. And it looks like this to start with before I blew it up. The bad news is that every language, the way you write regular expressions can differ slightly from between languages. So PHP has a slightly different syntax for regular expressions than JavaScript or Python or Go. But the good news is those differences are way out on the margins where you're not likely to encounter them at first. Yeah?
So with C#, putting the @ sign and then quotes around it kind of signifies its regular expression?
No, that's different.
That's different.
@ sign before a string means that you don't have to backslash special characters.
Oh, okay.
But it's useful for regular expressions. But, I mean, think about this. Suppose you had a regular expression, you want to match a backslash. Well, backslash is a special character. So the regular expression would be backslash, backslash. Now suppose you took that and wanted to have a Java string that consisted of backslash, backslash. You would have to backslash each backslash. So you got backslash, 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 backslash. In C# you would put @ sign, double quotes, backslash, backslash. Anyway. So I'm using JavaScript seems to work out well, so I'm using JavaScript's flavor of regular expression. Now I'm going to zoom in a little bit. All right, and the way it works is up here we insert the regular expression, and then you can see what it matches down below. So let's write a regular expression that'll match a University of Utah ID number. Okay? So that's U, 00 or whatever. Yeah?
So brackets U 0-9, then.
Okay, so you say U 0 through 9.
And then, well, an asterisk after the 0 through 9.
Okay, so let's look at that. Now, what it's doing over here on the right is it's sort of explaining, that's a place you can learn about what you just said. All right, so let's critique this thing. So what he's saying is it's U or a digit any number of times. So is that what a university ID number is? Yeah.
You need the U separate.
Okay.
I think you would also potentially want to account for both cases.
Okay, so there has to be a U, but there's only one U and it has to come first. Then what follows the U? 7 digits, no more, no less. So we don't want star. So we just use this construction. Oops. Okay, so U, then 0 through 9, 7 times. So now we can come down here and test. So I'm going to say, hello, it hasn't matched yet. Now I'm going to say U00823881. And it matched. Okay? And then I can say world, and I can say U, and it finds another match. So when the regular expression is applied to the string, it's just looking for all the matches it can find. Okay? So what happens if I put another digit? It still sees it as a match. The 4 isn't part of the match, but the U followed by 7 zeros looks fine. So you can put things in, like there's a pattern that says that it must be followed by it's called a word break, or something other than a digit or a letter. But we won't get into that. Just be aware that it's literally doing what you tell it to do. Now, what if we wanted to match? What if we wanted to match only if the entire string consists of a single unit? So we don't want to match A, B, C, D, E, F. We only want to match the string if there's nothing but a unit on the line. What did I tell you to do?
Put a caret at the beginning.
Right, so we put a caret at the beginning. And that matches no character, it just matches the beginning. And $ matches the end. And suddenly there are no matches. But if I pare this down so that all I've got left is just exactly the unit, great. So which is preferred? The regular expression that just matches the string that we want, or a regular expression that'll match the string anywhere it appears in some longer string?
Well, it depends on the program you're writing.
Right. Depends on the program you're writing. If you want to redact Social Security numbers, you want to match every Social Security number and then just get rid of it. If you're trying to find out whether a token that just got given back to you is a unit, you want the second form. You want to match the whole thing. Okay? What would Social Security number look like? Yeah?
Brackets 1 through 9.
Okay, so he said brackets 1 through 9, but I'm going to show you another way. So \D is any digit. So what would Social Security number be? We could do \D and then 3 in braces, yeah?
Why is any digit only pulling up? Oh, no. It says 7 matches.
Yeah, so that \D is currently matching all 7 of these digits. It's using different shades of blue so you can see the difference. Over here on the right, it shows you what's being matched. All right, so I could do that. I could just say 3 digits, 2 digits, 4 digits. That's one way to do it. And we're good. Now, I'll tell you another little trick. Let's see if this works first of all. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it matches it. I'm always being asked for the last 4 digits of my social. So if we're going to scrape Social Security numbers out of some document, we might as well also grab the last 4 digits so we can use them. So what you can do, parentheses are used for grouping, but they're also used for capturing. So I'm going to put parentheses around the last 4 digits of the social. And it matches just like before. The parentheses are essentially ignored. It matches just like before. But I want you to notice over here. It says that it found one match. The full match is 1, 2, 3, 4, 5, 6, 7, 8, 9. Group 1 is the 6, 7, 8, 9. So when you put parentheses in regular expressions, each set of parentheses is called a group. And the regular expression matcher will tell you which part of the overall match corresponding to the group. So it gives you a way of pulling out pieces. So what if we wanted to pull out the first 3 digits as well? What would we do? Right, we put a left paren there and a right paren here. And now it's telling you, okay, the first 3 digits were 1, 2, 3, the last 4 digits are 6, 7, 8, 9. So now you can pull things apart. Okay? Who could think of another pattern we could program in here? Yeah?
Credit card numbers?
Credit card numbers, well, that's kind of simple. It's like, at least in mine, 16 digits, I think. Groups of 4. Okay. What else? What's that?
Phone numbers.
One more time.
Phone numbers?
Phone numbers, okay. What would a phone number look like?
Sometimes an area code.
Okay, so maybe an area code. Do we want our area code to be in parentheses?
Yes.
It can be. Exactly.
Okay, well let's do it. Let's get started this way. Suppose we want to be of this form. Okay, so the idea is that we have area code in parentheses, followed by a space, then 3 digits, a hyphen, 4 digits. Yeah. Now yep, we do. So if we do 801, 581, 7079, I don't get a match because, as he just said, the parentheses are being used for grouping. Right? They're special characters. So what I need to do is say I really mean parentheses. So I'll put a backslash in front of each one to quote it. I think that's the right place. Okay, now we get a match.
Poker hands.
If you still wanted to capture that area code, you could just put parentheses around that still. Right?
Okay, suppose you want to capture the area code. We could put parentheses around this whole thing now. And now we're capturing the area code over there. What'd you say?
Poker hands.
Poker hands, okay. That's the late answer to my question.
So, with that like group 1 over there, in C#, is there any way that you can just grab that specifically? Like, okay, you found this match, now go and grab
Yes.
group 1 and do stuff with it.
Right, so in C#, Java, Python, JavaScript, whatever, they all have different ways that they make regular expressions available to you.
Okay.
At the heart, you're still writing regular expressions just like this. And it provides methods to match and to extract the groups. Right, so it's really simple. There are ways to do replaces. You can say, for every match, replace it with this thing. But that's a different topic. Right now, we're just trying to master what's going on up here. Yeah.
Now with using the question mark to be like, it could have this or not.
Okay.
If you put it after one of those,
Okay.
it only take that one character before.
Let's make the area code optional. So I'm going to do this here. So I'm putting what I did was I made the space part of the area code. So what we have in the regular expression is left paren, left paren, digit, 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 right paren, space. That's our area code. And now I'm going to make it optional. Okay? So I've made the area code optional by putting a question mark there. So let's see if that worked. Okay, so now it matches without the area code. So that question mark makes it work that way. Okay? Any other questions I could answer with this example here? Yeah.
Could you use Booleans with this?
Booleans in what
Well,
sense?
like Booleans is in if the number fits this format and
no, I don't. Okay, so I see what you're after. And no, you're limited to describing patterns.
Okay, I'm just trying.
Yeah.
So that question mark would work if they did like 1, 801, 581.
Okay, so what if they do put a 1 first. Okay, so it's not matching the 1. And so if we wanted to put an optional 1, we could. We could say a 1. So it starts to get complicated. What I tried to do is say left paren. I think I screwed it up. Okay, I'm going to back off there.
You don't need it.
It gets complicated. Yeah, I could make an optional 1. You sort of get the idea. I want to do one more pattern. Who could suggest a pattern that takes a minute? Yeah.
Email address?
Okay, what about an email address? I like that. So what makes a legal email address? Yeah, I don't know the exact one. Why don't we say
A string of letters or numbers.
a string of letters or numbers. So what will match any letter or number? Let's go over here to the cheat. Over here it'll show us any digit, any non-digit, any word character. I think that's pretty much what we want. So backslash W, backslash lowercase w will match a word character. Okay, so let's say we need, how many word characters do we need to start?
At least 1 or more. At least 1 or more.
Yeah, so we'll do plus. And then we need an @ sign. And then what do we need? We need some number of word characters. Let's say we need at least 1 word character. Then we need a dot. And then some more word characters, another dot. And I'm going to finish it off. Bear with me and I will fix it. Okay, I've got backslash W plus, and then I want to have slash, I want dot, and then word character plus 1 or more times. Okay, let's see if I've succeeded. So I should be a@gmail.com. So I made it so that you have to have at least 1 dot on the right-hand side. But you can have any number that you want. So you can now say ab.cd.ef.gh.ij. Anyway, I learned how to do it. I don't know if you did, but it's possible.